All right, everybody, we had a pretty tricky inequality question that a lot of people were stuck on because it's not really immediately clear how to do it from the information that's given to you. So I've got Desmos here just so that the graphs look a little nicer than what I draw by hand. So there we go. I gave you guys a bunch of points. So I gave you 0, 0, and 3, 0, and 2, 5, and -1, 3, and -2, 0, -3, -5, and 4, -2. So I just gave you a set of points. Some of them are in each of the quadrants, a couple of them are on the different axes, et cetera, et cetera. And then what I told you is I wanted you to write an inequality where 0, 0, 3, 0, 2, 5, and -1, 3 are solutions. So I wanted these points here to be solutions, and I wanted this one and this one and this one to not be solutions. And a lot of you were like, well, how am I supposed to come up with that inequality? And that's a really good question. So what I'm going to do is when we have a graph, a two-variable graph, an inequality is going to look like a boundary line and then some shading either above or below the line. So I'm just going to hand draw some boundary line like that. So imagine that line is just above those 2 points that I X'd out that I don't want to be solutions. And then let's try to figure out the equation of that boundary line. The way I drew it, it looks like it hits the y-axis at -1. So -1 is my B. And the way I drew it is, it looks like it goes, oh, oops, I'm noticing that that's actually one box down. I'm sorry, but that's not one whole unit down. Look at how my boxes here are each a half unit big. Like the number 2 right here is 4 boxes up. So I'm actually going to have to, I'm going to have to change that. Instead of -1, we'll make that into -1/2. Or you could do -0.5 if you want to. Then I notice that my line that I drew goes down 1 and over 4. So it goes down 1 and it goes over 4. So my slope is down 1 and over 4. Even though I'm counting half boxes, down a half box and over 4 half boxes is the same as down a whole box and over 4 whole boxes, because the ratio is the same. So let's try to type that in. Let's see if that's what we drew. Y equals -1 over 4 x minus 1/2. Okay, and that looks pretty good. So let's see, does that hit this point? Yeah, it looks like it does hit -2, 0 right on the dot. It goes above this. Okay, so here's what I want though, is I want to have a shaded area that gets all the points I circled that are called solutions and misses all the points that are X'd out. So I don't want to include the boundary line. I don't want to include -2, 0. I'm going to change my equation from equals to greater than. Notice what happens when I did greater than. Desmos knew greater than means you cannot equal the boundary line. So the boundary line is dashed, which is showing that this point, -2, 0, it's not actually being shaded in. -2, 0 is on the boundary line, but it is not a solution because it's not shaded in. It's a dashed line. If it was a solid line, if I made this change, if I said greater than or equal to, now, you see that line solid? Now -2, 0 is a solution. I don't want it to be a solution, so I take away the or equal to part. And so this is one example of an inequality that shades in the 4 dots that I wanted, but does not shade in the 3 dots that I don't want. Okay, so that was the first problem on there. Okay, the next problem has, and I'll just leave that up so you can see it there. The next problem has the same points, but it just changes which ones we want to be solutions. So we'll just go over the process again. The second problem says we want 2, 5, we want -1, 3, and -2, 0 as solutions. And we want 0, 0 to be on the boundary, okay? So I want to write a boundary line that goes through 0, 0. Well, if I write a boundary line that goes through 0, 0, I can write y equals, and I can put any slope. I just wrote 2x. And I could write plus 0, or I can just leave it without a plus 0. Either way is the same. Oops. And you can see that that puts 0, 0 on the boundary. It doesn't say that I want 0, 0 to be a solution. It just says I want it to be on the boundary. Okay? And it doesn't say anything about the other points. It doesn't tell me anything about the other points. So they might be solutions or not. So what I'm going to do is I'm going to change this to being greater than 2x. And now you can see that the 3 points that are shaded are the ones that I had checked off as wanting to be solutions. And when I see here that I typed, okay, it has, I want to have 0, 0 on the boundary, I have 0, 0 on the boundary. I suppose it's not wrong for me to make it a solid boundary. Now I just made it a point on the boundary that is also a solution. Okay? Now I want you to point out that those 2 inequalities both shade in these points right here. So these points right here are solutions to both of the inequalities. If you look at those inequality statements and you try out the numbers in the point, it works out. Like for example, I will do -1 and 3. If I check, is 3 bigger than or equal to 2 times -1 plus 0? That is true. -2 plus 0 is smaller than 3. 3 is bigger than that. That's why it's a solution. The other inequality, the green inequality, is a little harder. You're asking yourself, is 3 bigger than -1/4 times -1 minus a half? All those fractions and negatives can be kind of hard. But I think that you can agree that 3 is bigger than 1/4 minus a half. Even if finding out 1/4 minus a half is a little hard, you know that the number 3 is bigger than that. So we know that's why it's a solution to both. That's why it's a solution to the system. Okay, so please let me know if you have any questions. Happy to help out. And thank you for watching.